I have some good news regarding being able to debug I2C. So what I have here, first up, is a thing called the OpenBench logic analyzer. It cost me 50 bucks. It's like 5 years old, so stable, but it also hasn't really seen much development. And what I also have here is, just for prototyping purposes, two just ordinary Arduinos. These happen to be SparkFun Red boards, and they are programmed with a little bit of I2C software. So this one, I've got a little tag on it that says master. This one, tag slave. I'm just running it through a USB bus. So what I did first was just a quick search on Arduino, and I found this master reader slave sender article, and I've just taken the code that's in here and written it out to the Arduinos. So there's code, and that's just what the wiring. You basically wire clock together, data together, and ground together. And then what happens is, over in Arduino land, the master will just send what is being received on the slave. So you're just seeing the word hello, hello, hello again. So that was a case of I2C running across these two Arduinos. So then I wanted to actually get my protocol analyzer involved with the OpenBench. So rather than going direct from master to slave, I go through a very simple little breadboard here where I actually put the signals out to the OpenBench as well. So again, everything's coming along. And then what I did next was to go to the OpenBench software, and I did a capture. And what I had as an acquisition speed was 500 kilohertz, channel group 1, 24K, which is the maximum it wants to record, which is pretty small. So it's easy to not get the time you want. So you go to trigger, and then because I know I've got the clock on 0, all I did was just say, give me a trigger on that clock. Simple. Before after rate, it doesn't really matter because it's just going to capture just that middle bit. Then I press capture, so I'm going to press capture again. Actually, I'm not going to do that because I'm going to show you the results that looked good one time. And so, as you can see, here's a protocol. I know that 0 line is the clock because I purposely chose for that. And here's the data going across. And then up in the Logic Analyzer client, and this is free software. This is I2C protocol analyzer, which I then said, hey, analyze protocol. And lo and behold, there we get the bytes that we know are going across the wire. There's H, E, L, L, O, and then that ends that transmission. So we could see, I'm going to close this out, see that this was actually, oops, that's zoomed in, zoom all the way out. You can see it's just a tiny little bit in the middle. I'm going to do it again just for giggles. So again, I'm with capture, keep information, 500 kilohertz. What the heck, I'll go for a 1 megahertz. It doesn't really seem necessary, but why not? Keep the same triggers, 24K sample, and capture. And it's going to have that signal with a little bit higher resolution because of the better capture rate. So again, we get that. We go to Tools, go to I2C Protocol Analyzer, press Analyze. Again, HELLO. So I am able to snoop an I2C line, which is what I need to do in order to move on to the next level of the project.